Hello, welcome. This is day 13 of Leetcode 75. We're doing reverse linked list, and this is problem 206. And we're given the head of a singly linked list. We have to reverse the list and return the reverse list. So we have, like, say we have 1, 2, 3, 4, 5. A linked list is just a structure where you have a value of a node. So you have a node and you have a value, and then that node that you're at, it has a pointer to the next node. And the only way that you can access like the end of the list per se is that you have to iterate through all of this entire list to get to the end of the list, to get like the last element or something. And to cut off the list, or to like define the ending, you say the next is equal to none, which we have in our default values here. So that's how you define the linked list. Our goal here is to reverse the direction. So basically we want to say like 1 to 2 to 3 to 4 to 5. We want to flip that, say 5 to 4 to 3 to 2 to 1. And you have some more examples here that make it easier to kind of understand the process of this. So there's two solutions. There's an iterative and a recursive solution, and I'll try to implement both today. So let's understand how the recursive solution works. So we're doing a recursive solution. So you have, let's start with an easy case right here, 1 to 2. Okay, so you want 1's next value to be equal to none, and you want 2's next node to be 1. Okay, so how can we do this? So what we can do is we can store it's better to like write it up right now so that we know. So all we have to say is that we're going to keep track of 2 pointers, which make this as easy as possible: a previous and a current. The previous right now will be set to none, since we'll start from like almost the left hand side. The current one will be set to the start of the list, which is just 1, okay, which is the head. Okay, so when we have this, we're going to set 1's, since we know that 1 always has to be the end of the list, we can set it to be previous exactly. So 1 his next value is going to be set to null, but you have to also account for the fact that we're going to lose this reference to 2, since we're resetting this arrow, this pointer, to become none, to be pointing to none. So we have to store this reference to 2 before we modify 1's pointer. Afterwards, we'll go to 2 and do kind of the same thing. Okay, so we'll have 2 variables that we set here, previous and current, which is just equal to none and head. Then we'll say that while the current is not equal to null. And that's very important because when the current does hit none, previous will be our new head, because by that point we're going to be moving current all the way down. We don't want to miss anything, so we have to make sure that current becomes null before we can return the entire new list. So we'll return previous as our ending. Okay, so the temporary is going to be equal to the current dot next, like we said here, so we stored the 2, and then I'm going to say that current dot next is equal to previous, and yeah, so that means that we'll set 1 to be equal to the previous one, and then we'll do the same thing for 2, which is set to 1 when we go to that next loop. So now we have to reset our variables here. So previous is going to be equal to temp. Previous is going to be equal to the current, and current is going to be equal to the temp. And that is the iterative I meant to say iterative. This is the iterative solution, sorry. This is the iterative solution to this problem. Now the recursive solution is a little more finicky, because we have to really utilize this concept of like our stack frames and popping it back up. So the best way like I can visualize this is that the base case is obviously if the head is equal to none, because there's nothing to reverse in that case, right? But the other one is that So the way that we should think about this is subgrouping problems, like as we said, narrowing it down all the way down to the base case. That's always what recursive solution. So we have to think about the base case, the recursive leap of faith, and also just like our main raw logic for how we would flip um, an entire or in this case, how we can take subproblems and reverse them, then allow them to be part of bigger problems, right? So what we can do here is that we can think about how we have 1 is pointing to this group of 2, 3, 4, 5. Okay, and then we do the same thing. 2 is equal to this group, or like is pointing to this group of 3, 4, 5. 3 is pointing to this group of 4, 5, and 5 is and then 4 is pointing to this group of 5 null, and 5 is just pointing to the group of null. So when we get to the group of 5 to null, we know that there's not much to change here, right? Because 5 is already pointing to null, and that's like the start of our new list essentially, right? So we want to make sure we store our reference to 5, and we're gonna, when we come back up to 4, we're gonna do something interesting here. So we're gonna set 5's next value to be equal to 4. And then what we're going to do is we're going to cut off 4's next references. So it'll lose this reference to 5 before it creates a cycle, essentially. So what's going to happen here is that when we narrow our problem all the way down to 4 to 5, so right now it's going to look like this. And then what we're trying to do is in the intermediary step, what's going to happen is going to be 4 to 5 to 4, right? Which is probably going to be creating some sort of cycle here. But then we'll cut off 4's reference. So it'll be 4 is to none, but then it'll be like 5 to 4 to none. So we're really trusting in this pointer, like in this temporary pointer locations. Okay, let's go ahead and try to code this up. So we'll say that if head is if not head, return none, right? And then we're gonna say here that the new head is equal to head dot next. Now if head dot next so we'll say that if head dot next, we're gonna make that recursive call here, which is gonna set our new head to be equal to self dot reverse this on head dot next. And then we'll say that our head next is equal to our head dot next, and then we'll cut off what we said, we'll cut off that reference, and then we'll return the new head. Let's see what I did wrong here. Let's see. That's right, not a good idea. It should be equal to head, right? Next should be equal to head, so that's right. Head's next will be equal to none, so we cut it off. So I'm assuming this portion that we did something wrong here. So what should the new head be realistically? So if not head, then return none. So let's think of like 5 to none. The head here should still be, there we go. Yeah, okay, yeah, because if we go to none, then we're just gonna always be returning like so like if we had like 5 to none, then we're gonna be always returning none, but we want to keep that reference to 5 here because we're gonna get new head's gonna be equal to none, we're going to skip through this block since it's equal to none. And then we're going to set none, like the next to be none. So we're just getting like an empty, we're emptying out a list node. But if we keep it to 5, then we'll say that it doesn't have a next value, but we'll set the next value to be none. So that meets that initial condition. Then we go to 4 to 5. So if we had 4 to 5, then what we'll do is we'll say that the new head is equal to like 4 for now, but it has a next. So we'll say that the new head is equal to, when it does the reverse list of head.next. Oh wait, we already did that problem, right? So new head is going to be equal to 5 to none. Then the heads, so 4 is our head right now. Next is equal to the head. That's what we said, we'll make the cycle. Now we'll say that this head is next value. We'll cut it off. We'll cut off this next value. It won't be connected to 5 anymore. So then we get rid of that link, and it'll be 5 to 4 to none now. And then we can return a new head, which was always 5. And then that should be our solution. Yeah, so that's how you solve reverse lists with an iterative and a recursive solution.